Welcome to 8.4 Notes. Today we are talking about dividing radicals, but we have a quick warm-up here. So today we're just going to focus on this concept that I talked about in our multiplying radicals. But when I have radical 11 times radical 11, right, we could multiply them together and get radical 121 and then say, hey, that's a perfect square of 11. But our goal here is to kind of eliminate this step and go right to this step. Okay, so when I see one like radical 24 times radical 24, right, skipping that middle step, and I'm just going to say, well, that has to be, I don't even know what 24 times 24 is, right, but I know radical 24 times radical 24 is regular 24, and that's the key that we need to focus on today to help us with dividing radicals. I know it seems weird that dividing radicals is going to involve multiplying radicals, but there you are. So our vocabulary today, right? So just a little refresher about our fractions. Top of a fraction is called the numerator. Bottom is called the denominator. I always remember this as the debottomator. So denominator is the bottom number in the fraction or the bottom of the fraction. Numerator is the top of a fraction. Our new vocab word is to rationalize. So that means turning a radical that can't be simplified into a non-radical number. Okay, so what we're going to be doing is we're going to be rationalizing the denominator, okay, which means anything that we have that's a radical in the bottom of our fraction, we have to convert to a number that's not a radical. So here is some examples of dividing radicals. So we're not allowed to have a radical in the denominator of the fraction. So in order to deal with this, we simplify any inside stuff or outside stuff. So that was like your 8.2 notes, or 8.1 and 8.2. If there's still a radical in the denominator, we multiply both the top and the bottom by the radical in the denominator. So we're going to make a fraction, right, that's going to be the same thing on the top and the bottom. Then we're going to simplify, and there should be no radicals left in the denominator. If after doing this process there are still radicals left, we may have done something wrong, or maybe didn't multiply by that radical in the denominator. So let's do some examples here. So our first example is 3 divided by radical 5. So remember, this right here, that's no bueno. All right, we're not allowed to have that radical in the denominator. Regular fractions are fine. We've seen those before. But we can't have a radical in the denominator. So what we're going to do is multiply by that radical in the bottom and the top. Okay, if we remember from fractions, we multiply across. So the top of this is going to be 3 times radical 5. And the bottom of this, remember, this is like our warm-up. Radical 5 times radical 5 is regular 5. Skip that middle step. Just make it regular 5. And then we're going to check. We have 3 and 5 outside of a radical, but we can't simplify 3 over 5, right? If I just said 3 over 5 as a fraction, we can't simplify it, so we're going to leave it alone. Okay? So let's move on to B. So this one is radical 3 over 2. So the whole thing is in the fraction, or in the radical, right? So the first thing we're going to do is break that up and make radical 3 on the top, radical 2 on the bottom. So we're just breaking this into 2 pieces. Both parts are in radicals. That's okay. So now this is no good, right? No bueno down here. So we have to get rid of the radical 2 in the denominator. And we're going to do this by multiplying the top and the bottom by that radical 2. When we do this, radical 3 times radical 2 is radical 6. Radical 2 times radical 2 is regular 2. And I can only simplify if both numbers are in a radical, both numbers are out of a radical. So I cannot simplify radical 6 over regular 2. There's nothing to simplify. So we're done. So for C, right, here we have something that we can simplify. So if I look at my outside numbers, I see 6 over 4. So if I just said the fraction 6 over 4, we can simplify this, right? Because these are both divisible by 2. So if I divide the top and the bottom by 2, same way we're multiplying the top and the bottom by the same number, I can divide by the same number. This really becomes 3 over 2. So I'm going to rewrite this as 3 radical 3 over 2 radical 5. So we just simplified the 6 over 4 to 3 over 2. Okay, so now what I need is I have to get rid of this radical 5. All right, the radical is no bueno, but just the radical part, the 2 is fine. So I'm going to multiply by another copy of radical 5 on the top and the bottom. Not the 2, just the radical part. Okay, so now we're going to multiply across, right? So 3 is just 3. Radical 3 times radical 5 is radical 15. And then on the bottom of this fraction, we have 2. And then radical 5 times radical 5 is regular 5. So this ends up becoming 3 radical 15 over 2 times 5 is 10. Can't simplify 3 over 10, so we are good to go. And our last one here, our last one on this screen is radical 3 over radical 12. So I could go ahead and multiply both of these by radical 12, but I also noticed since both of these numbers are inside a radical, I can simplify this fraction. So we can almost, like kind of the opposite of b, we can almost put them both back under a radical and say, hey, 3 over 12 simplifies, right? Those are both multiples of 3. So 3 over 12 is really 1 over 4. Right? And if I separate those back out, so I kind of, and like this part can kind of happen in my head a little bit, but I know if they're both inside a radical, I can simplify that 3 and that 12, right? So this becomes radical 1 over radical 4, and those are both perfect squares, right? The square root of 1 is 1, and the square root of 4 is 2. So this ends up just becoming 1/2. So there we go. We didn't even need to simplify. All right, let's do a couple more examples here. So for this one, again, we have the numerator and denominator are both inside the radical. But if I notice here, I can simplify that radical. So 32 divided by 2, I can do this part first. So this number is still going to live inside a radical, but 32 divided by 2 is 16. 16 we should recognize is a perfect square. So I can actually just simply evaluate that as 4, and we're done. So sometimes we don't even need to rationalize the denominator because the denominator gets rationalized along the way. In our next one, we have a couple of options here. I could simplify radical 4. I could also simplify the radical 4 over radical 8. I think I'm going to do that. I'm going to simplify 4 over 8, right? So 4 over 8 is really 1 over 2. So if I rewrite this, it's really radical 1 over radical 2. So now I still need to rationalize this denominator. So I'm going to multiply by another copy of radical 2 on the top and the bottom. Radical 2 times radical 2 is just 2. And radical 1 times radical 2 is radical 2. And there we go. Our denominator is rationalized. We can't simplify because I have one number inside a radical and one number outside of a radical. So that's our answer. If I look down at G, things are getting a little bit more complicated. All right. So again, we want to try to simplify as much as we can before we do that rationalizing step. So I'm going to look at the numbers outside of my radical, right? 3 over 6. 3 over 6 simplifies to 1 over 2. The next thing I'm going to look at is my radical 14 and radical 42. So those are both divisible by 14. So radical 14, if we divide that by 14, is going to be radical 1. And 42 divided by 14 is radical 3. So already a lot simpler. Okay, now all I need to get rid of is this guy. So we're going to multiply by another copy of radical 3 on the top and the bottom. So when I multiply across 1 times radical 3, I can multiply that inside stuff together. So it's 1 times radical 3. Then on the bottom here, I have 2, and then radical 3 times radical 3 is a regular 3. So 2 times 3 is 6, and 1 times radical 3 is just radical 3, right? I can kind of get rid of that 1. I don't need it there. And finally, our last example here, we have radical 18 over radical 27. Again, I don't want to multiply by radical 27 on the top and the bottom because 27 times 18, I'm going to have to go to my calculator, and I try to avoid that if I can, right? So let's see if there's a better way. So can I simplify 18 and 27, right? What number goes into both 18 and 27? So we might think of 9. So we're going to divide both of these by 9. So this is no longer multiplication. I am just saying that these are divisible by 9. So 18 divided by 9 is 2. So we're going to have radical 2. And 27 divided by 9 is 3. So now it's radical 3. Much smaller numbers, much easier to work with. Less simplification to go along the way. So now I multiply by radical 3 on the top and bottom because that's this number down here. Radical 2 times radical 3 is radical 6. And radical 3 times radical 3 is regular 3. So we are done. Thanks for joining me.